When you picture living on the moon, what comes to mind? Probably glorious scientific triumphs, sleek, futuristic habitats, and the sheer pride of exploring the cosmos, right? Well, behind that highly romanticized sci-fi vision is a brutal, invisible reality. The lunar environment isn't just challenging. It is a wasteland that is fundamentally incompatible with human biology. Welcome to this explainer, where today we're going deep into the major physiological and psychological challenges of living on the moon and the ingenious ways we're actually engineering our survival.
To set the stakes, just consider this terrifying reality: 90 seconds. If you were to somehow step out onto the lunar surface without a pressurized suit, you wouldn't just freeze instantly like you see in the movies. Instead, you'd face a hard vacuum with pressures so low it's almost incomprehensible. Within roughly 9 to 12 seconds, as deoxygenated blood reaches your brain, you'd experience rapid oxygen starvation and pass out. By 30 seconds, this horrific condition called ebullism kicks in. That's a fancy way of saying gas bubbles actually start forming in your bodily fluids, causing your soft tissues to bloat to almost twice their normal size. And at 90 seconds, ice starts forming in your respiratory tract, and death is absolutely unavoidable. The margin for error up there is literally zero.
You know, for millennia, we've looked up at the moon and seen this beautiful, romantic beacon in the night sky. But when we transition from treating it as a quick place to visit to a permanent place to live, our whole perspective has to radically shift. We need to start looking at the moon as a hostile eighth continent. It has no atmosphere, no global magnetic field, and it's geologically dead. Every single element of this environment acts as a direct active antagonist to the biological systems that we've spent millions of years evolving here on Earth.
Okay, let's dive into this and map out our survival guide using NASA's RIDG framework. Today we're looking at 1. Gravity's toll on the body. 2. The toxic threat of dust. 3. The silent radiation danger. 4. The psychology of extreme isolation. And finally, 5. How humans will survive.
Starting right off with Section 1, Gravity's toll on the body, and the major problem of 1/6 gravity.
Right now, sitting on Earth, your body is in a constant, invisible wrestling match with gravity. That everyday mechanical stress is exactly what tells your bones to stay dense and your muscles to stay strong. But up on the moon, surface gravity plummets to just 1.62 meters per second squared. Without that constant downward resistance, an astronaut can lose up to 20% of their lean muscle mass in just a matter of weeks. Our bodies are ruthlessly efficient. If they don't need to support heavy mass, they just stop spending the energy to maintain it. And alongside that muscle atrophy, astronauts are losing 1 to 2% of their bone density every single month. To put that into perspective, that is a rate of bone loss that would absolutely terrify an osteoporosis patient down here on Earth, and it happens incredibly fast.
So the really crucial takeaway here is that this lack of gravity doesn't just mess with your muscles and bones, it fundamentally rewires your circulatory system. Without gravity actively pulling your blood down toward your legs, all those fluids shift rapidly up toward your head. This upward shift causes a very real condition astronauts call moon face, where your facial tissues swell up dramatically. It can even increase pressure inside the skull, leading to dangerous and sometimes permanent vision changes. And get this, because your heart isn't working as hard to pump blood upward anymore, the muscle literally shrinks. Your total blood volume drops, leading to a serious condition known as space anemia.
Moving right along to Section 2, the toxic threat of dust, or why you'd basically be breathing glass.
Now, you might be wondering, dust? Really? We tend to think of dust as just a mild annoyance you sweep off your bookshelf. But lunar dust, or regolith, is an absolute nightmare material. During the Apollo missions, every single one of the 12 astronauts who walked on the surface experienced what was quickly dubbed lunar hay fever. When they tracked this gray dust back into the lunar module, they noted it smelled just like burnt gunpowder, and it gave them severe sneezing fits, sore throats, and nasal congestion that stuck around for days. See, dirt on Earth is smoothed out by wind and water over thousands of years, but the moon has zero erosion. When a micrometeoroid smashes into the surface, it shatters the rock into tiny glass-like shards, and without weathering, those shards stay razor-sharp. Worse yet, constant bombardment from solar radiation leaves these particles highly electrostatically charged, so they literally static cling to everything.
When you look at a cross-section of the regolith, it becomes glaringly obvious that this isn't just some light surface dusting, it's a deep, pulverized debris blanket. This stuff is so unbelievably abrasive that it chewed right through layers of Kevlar-like fabric on the Apollo spacesuit boots and totally destroyed the vacuum seals on their sample containers. Biologically speaking, it's a disaster. If particles under 50 microns are inhaled over a long period, they penetrate incredibly deep into your lungs. Research actually shows that breathing this stuff can cause cellular mutations, destroying lung and brain cells through oxidative stress. So yeah, you are quite literally breathing in microscopic shards of glass.
Which brings us to Section 3, the silent radiation danger and the invisible attack on our biology.
Okay, so if the vacuum doesn't get you, and the toxic glass dust doesn't get you, the radiation is definitely waiting. The moon doesn't have a thick atmosphere or a massive magnetic field to act as a lead shield like Earth does. So the surface is completely exposed to a non-stop barrage of galactic cosmic rays, plus totally unpredictable solar particle events from our sun. On the lunar surface, you're looking at a dose rate of about 60 microsieverts per hour. That is a staggering 200 times higher than what we experience standing safely here on Earth. It's even 2.6 times higher than what astronauts get hit with on the International Space Station, mostly because the ISS is still safely tucked inside Earth's protective magnetic bubble. This lunar radiation silently passes right through habitat walls in standard spacesuits, directly attacking your DNA, causing mutations, and drastically spiking your lifetime risk for severe cancers.
Let's shift gears now to Section 4, the psychology of extreme isolation and surviving the ice environment.
Surviving the physical threats is really only half the battle. The human mind is just as vulnerable. Space agencies categorize the moon as an ice environment: isolated, confined, and extreme. Just think about the immense psychological toll of being locked inside a highly confined box, knowing you are separated from everything and everyone you've ever known by a cold void measuring 384,400 kilometers. The stressors pile up unbelievably fast. First, your circadian rhythm is completely wrecked. A single day-night cycle on the moon lasts about 27 Earth days, which severely messes with your sleep and triggers severe insomnia and depression. Then there's sensory deprivation. Astronauts report profound Earth sickness. They deeply miss the grounding sensations of human life, the smell of rain, the feeling of real grass underfoot, seeing a blue sky. Add in the social stress of extreme confinement with the same few people, and crew friction becomes highly combustible.
The NASA Human Research Program actually equates this massive psychological burden to working long-term on a cramped submarine. Over extended deployments on the lunar surface, the motivation of the crew naturally begins to degrade. And this brilliantly illustrates that it isn't just about feeling lonely. Long-term sensory deprivation and confinement actually impair your cognitive functions and your ability to make sound decisions. In an environment where one tiny slip-up can vent all your oxygen into the vacuum of space, maintaining mental sharpness is quite literally a life-or-death requirement.
Finally, let's look at Section 5, how humans will survive, and how we're engineering a future up there. Despite all these terrifying, formidable hazards, human ingenuity is just relentless. We aren't just figuring out how to visit the moon again, we are engineering a way to stay. By utilizing in situ resources, which basically means using the materials that are already lying around on the moon, we are developing some incredibly robust countermeasures. To beat the radiation, we have to build smart. Step 1 involves integrating hydrogen-rich materials right into the habitat walls to absorb fast-moving neutrons. But Step 2 is where it gets really clever. We are going to use the very toxic regolith that threatens us to bury our habitats. Piling 1 to 2 meters of compacted lunar dirt over a structure provides a massive physical barrier that's thick enough to scatter and absorb incoming cosmic rays and solar flares. We are effectively building safe underground bunkers.
Now, inside those bunkers, surviving requires a totally uncompromising daily blueprint. To fight off that crazy 1/6 gravity bone and muscle loss, astronauts will have to endure over 2 hours of intensive resistance training every single day using specialized equipment. To combat space anemia and stop all those fluids from pooling in their heads, they'll likely use lower body negative pressure devices to literally pull blood back down toward their legs. For the toxic dust, habitats will be equipped with electrostatic shields and heavy-duty advanced air filtration. And crucially, to fight off the isolation, scheduled well-being sessions and structured leisure activities are totally mandatory. Studies show this actually speeds up the perceived passage of time and drastically cuts down on depression. And you know what's brilliant? This whole habitat architecture builds a completely holistic defense. Remember that continuous threat of high-velocity micrometeoroids? We're talking about tiny rocks traveling at tens of kilometers per second. Well, they are stopped dead by that exact same 1 to 2 meters of compacted regolith we're using for the radiation shielding. That dirt blanket acts as impenetrable armor, dropping the risk of a catastrophic habitat puncture to practically zero.
So we've mapped out the brutal hazards, and we are rapidly perfecting the engineering to beat them. We know how to build the shields, the high-tech filters, and the exercise machines. But the ultimate question still remains. The moon isn't just a shiny destination. It is the absolute ultimate test of human resilience. We clearly have the technology, But do we actually have the biological and psychological endurance to truly conquer the 8th continent? What do you think?